Hello there guys, welcome back to another epic inexorable maths video on double integration. So, in this video we're doing this following double integral. This is the integral of e to the power of y over x dx dy with those limits. And you might know something about this function because the integral is telling us that we need to integrate this function with respect to x first. And as it seems to be a reoccurring pattern with these double integration videos of mine, it's pretty difficult now to integrate something of the form e to the constant over x. In fact, it's impossible to do it with an elementary function. You can't integrate it. So we need to integrate this with respect to y first, because that can be done. That's just e to the power of a constant times y, or y divided by a constant. It's fine, you can do that. But you can't integrate this thing with respect to x. It's not possible. So we need to swap the order of integration. To do that, we can draw a picture of the region that we're integrating over, as always. Okay, well, what region are we integrating over? So these are x limits. This is x is a half y, and x is the square root of y. So let me write that down. X is a half y, and x is the square root of y. Okay, what does that tell us then? Well, if x is a half y, then y is 2x. Also, if x is the square root of y, then y is x squared. And the reason I'm doing this is because it makes it easier to draw these graphs. It's pretty difficult to see what this looks like, in my opinion, without just converting it. It's nice and easy to do this. So y equals 2x is a straight line graph looking something like this. This is y equals 2x. And a square root, or y equals x squared, might look something like that, roughly. So that's y equals x squared. Okay. So in the x direction, we're bounded between those two. In the y direction, we're bounded from 0 to 4. So y equals 0. Where could y equals 4 be? Well, I'm going to tell you guys, I actually might make this a little bit taller. 4, okay, imagine this was a straight line, will be here. This is the line y equals 4. The reason I know this is because when you substitute 2 into y equals x squared, you get 4. And when you substitute 2 into y equals 2x, you get 4. Meaning that this has to be the point 2. And they both correspond to, that when they're equal to each other, that's that point, and it's when y is 4. So when x is 2, making y be 4, if that makes sense. So that's how I know that. Okay, cool. And let's figure out what the region is, because as you can see, there's a few regions here. There's a kind of triangle, and there's also this weird kind of strange pea pod maybe shape. I don't know. So which one is it? How can we figure that out? Well, again, in the x direction, left to right, we're bounded leftwards by a half y, which is basically the same as y equals 2x. And to the right, we're bounded by y equals x squared, which means we must be inside of the p pod, right? Because that's the bounding. So let's shade this in. Like that. That's going to be our region. And we can verify that it definitely is by looking at the y limits. So y is bounding us from 0 up to 4. Well, y equals 0 is this point here. Y equals 4 is this point here. So it checks out. It's good. Okay. Right then, let's reverse our order of integration and see if we can make this thing integratable. If that's a word. I'm sure it is. Yeah, of course it is. Okay, so this is our integral. It's a double integral still. We don't know what the limits will be yet, but it's definitely of e to the power of y over x, dy dx this time. So we're swapping these guys around. We're doing y first because it's actually possible to integrate this with respect to y, but not x. Okay, so we need to figure out what's bounding us left and right. Down and up, because it's with respect to y. So it's down and up. Okay, So let's do it. Well, what function is bounding us from below, guys? In this p-pod here, what function is preventing us from going down? You might say, well, it's y equals 0. I'll say, you're right. But there's a function that does it too. The function y equals x squared is also going to stop us from below. So I'm going to use that one, and you'll see why. If you haven't already, you'll see why. So x squared will be here. Okay. And then what function is bounding us from above? Again, guys, you might say, well, it's y equals 4. So that's true, but we're going to use y equals 2x because that also bounds us from above, right? You can't go above 2x, so y equals 2x. So that's going to bound us from above. So x squared and 2x will bound us. Okay. The reason why I've used these functions instead of these straight lines is because the integral limits on the leftmost integral, the outside integral, must be constants. And we would, if we had described these limits in terms of constants, these would have to be in terms of functions, which they can't be. You can't have a function on the leftmost integral because your answer will be a function and you don't want it to be. You want it to be a constant. So that's the only way that it can be done. So what constants in the x direction, so this time, now it is left and right, will stop us? X equals what and x equals what? Well, we can see that nothing can get past, if they're coming towards me, nothing can come at me if I say you must stop at the line x equals 0, right? X equals 0 stops the region from coming towards me. So that's the lower limit, 0. What about what stops me from going to the right? Well, we can clearly see that it's going to be x equals 2. X equals 2. Because if I say you must stop at x equals 2, you cannot get past. So it's 2. I hope that that makes sense for our limits here. Let's then do the integration. So we've got 0 to 2. E to the y over x integrated with respect to y, that's possible. We can do that. So what will that be, guys? Well, that will be x e to the y over x from x squared to 2x. The reason, okay, is if you differentiate this, what you will get, and remember you're differentiating it with respect to y. So if you differentiate this with respect to y, the derivative of y over x is 1 over x. So the 1 over x comes down and it will cancel out with the x that's there, creating nothing in front and just e to the y over x, which is what we originally had. So this must be the integral. Okay. And we've got a dx on the end. Okay. Next step, simplify. 0 to 2, and then we're going to sub in. So we've got x, e, and remember the y's are being replaced by the 2x's and the x squareds, not the x's. So we've got x, e to the 2x over x. That's just x, e to the 2, because the x's cancel. And then we subtract x, e to the x squared over x. That's just x. So it's x e to the x, and then there's a dx there. Okay, and again, guys, this is a kind of typical, normal integral that can just be done with a little bit of integration by parts, hopefully not too much. I hope that you can see that up there. Leave it about there. Okay. Right, so let's split this into two integrals, actually. Let me stay on this board for a moment. I'm going to write this as the integral from 0 to 2 of x e squared dx minus the integral from 0 to 2 of x e to the x dx. Just to make our lives easier. Okay. Right. So the first integral, the integral from 0 to 2 of x e squared dx, that's a nice easy one. Because it looks a little bit deceiving, but actually e squared is a constant, isn't it? So this is just going to be a half x squared e squared from 0 to 2. Lovely. And we will evaluate this. We end up with 1/2 times 2 squared, which is 4. So half times 4 e squared. And then again, guys, we would be taking away some 0, but I'm not going to write take away 0 because it's just 0. So this actually just ends up being 2e squared. Okay, now the slightly more annoying bit is the integration by parts for the second integral, the one over here. Let's do that. So the integral of xe to the x dx. Okay, let's not actually like label it and stuff. I'm assuming that you guys are quite good at integration by parts. So if we kind of in our heads let u be x, then this would end up being, and this is from 0 to 2, this would end up being xe to the x from 0 to 2 minus the integral from 0 to 2. The x would be differentiated, and so it would just be e to the x dx. Okay, this is then equal to 2e squared minus 0, because it'd be 0e to the 0, minus, and then this integral here is just the integral, it's just e to the x, evaluated from 0 to 2. So that's 2e squared minus e squared, minus, and then which would become a plus 1, because it'd be like minus e to the 0, so there's a plus 1 there. So this becomes e squared plus 1. All right, now remember we were taking that integral away. So the first integral had a value of 2e squared. So the whole thing, like the whole thing, the first integral was 2e squared. The second integral is e squared plus 1, and we need to take that away. So it's minus e squared minus 1, which is e squared minus 1. And that's the answer. So this thing all along was just equal to e squared minus 1, just like that. Hopefully that's helpful, guys. A little bit more double integration. More of it is to come. But if this was helpful, please leave a like, subscribe, share it with your friends and family, and I'll see you in the next inexorable video.